Hello, my fellow gophers. Just a heads up that we are already recording because Aaron booby-trapped this room to record as soon as people log in. Speaking of Aaron, he is at a conference today. So I will be herding the gophers, so to speak.
I believe it's in good hands. It's a busy man, Aaron.
Oh yeah, it's a pretty intense job being a cloud advocate.
Yeah, I can think so. I'm having my dog beside me here, so I have to watch him from time to time.
Alrighty, so we've got a couple things in the queue for today, but first, thank you everyone for coming to the Go Study group. I'm gonna post a link in chat to all of our resources. That has our agenda and link to Zoom, obviously already on Zoom, etc. If you have ideas for what you'd like to talk about or you want other people to talk about, feel free to edit the study group Google Doc and add in a suggestion. For example, someone suggested that they'd like to learn more about hands-on with containers in Go. And so I have a section at the top of the doc where you can ask for stuff like that. And then Aaron and I can help find someone either within this group or outside who would be interested in leading a discussion about whatever the topic is. And for this week, we're going to be talking about HTTP handler and HTTP handler func. Anchor, are you online and ready to chat about that?
Yeah, Carolyn, hi.
Great. I will turn it over to you.
Yeah, just again. So whatever I have learned, I will share along with you guys. So if I am wrong at any place, you can feel free to interrupt me and give your feedback.
Sounds good.
Can you just give me 2 seconds?
Sure. I will do a tap dance for everyone on the phone while you get ready.
Yeah.
Sorry to throw you under the
I
bus.
was just having dinner. I just completed a Golang India meetup. So I was just finishing up my dinner. Just let me wash my hand.
Sure.
Yep. So let me share my screen. Okay.
Perfect. I can see it.
Yeah. Sure. Okay. Okay. So I assume people have bit of familiarity with writing Go services, or should I start with from the basic? Because that's how I learned. I started with basic, so I would like to cover thing from basic.
Yeah, that would be great. The Go study group is really for people with lots of experience and people new to Go. So if we could kind of start from the bottom, that would really help people, especially who are watching the recorded video.
Okay. So, okay. So we all are familiar. There are ways to different ways we can say hello world in, especially in the web server. So let me first give you example. One, so we all have written services like this, where we write a mux and then with handle func, and we provide a func that will execute on the basis of any routes. Means this is the root route. We all have written this, and then we have second way where we have, instead of handler functs, we use a type. So we use a type that gets that implement the serve HTTP. So we are so these are the two way in which we can write basic implementation of Go HTTP service. Okay. So how does so first, how does major means what are the major components when we try to handle the HTTP request? So in Golang we get package net HTTP, in which there are some components which handle these things for us. One is servmux and second one is handler. So what is servmux and what is handler? So first of all, we have seen that let me just, sorry guys. Okay. Let me go with this example. Okay, we all have seen, okay, this. So what is handler? Any method that any type that implements serve HTTP method is the handler type. So once we handler type, and what is the servmux? So servmux is basically what is the multiplexer. So any request that comes in, you need to register the routes. We all need to register the routes at some place. So servmux is, we can think of it as a structure that keeps record of all these routes and all those handlers. So based on each, let me show you with diagram what actually it means. It will make, yeah. So this is basically a servmux, you can think of. It keeps record of each of the routes that you register, and then for each route, what is the handler that it needs to invoke. So this is the overview of at the basic level of the servmux and the from the Golang perspective. So okay. So handler. So any type that implements serve HTTP becomes the handler, and whatever type that implements the serve HTTP can be used as a handler. So we have seen that here we are, this is the message type, and we, for that type we implemented serve HTTP. So it can be used as an handler. Over here we created an type value type of this, and then we used this as an handler. Similar for handler func. If we handle func, here we are simply passing the function, but we know that whatever we pass over here has to be handler func type, so that it can call the serve HTTP, because only handler type can handle your request. So how does this function type, which is means function, becomes an handler type? So okay. Yep. So yeah. So servmux, all the mux multiplexer, whatever mux we have, it is type in itself, and it has three functions: handle, handler func, and handler. So handle we have already seen over here with the handle over here. So whatever we give handle, it register that routes and the handler function. So let us go through the handle func. So what does handle func do? So how does it means handle func takes second argument as a function with signature this, and how does this handler becomes the HTTP handler? If you see over here, how does, so at the source means server mux level, we have something handle func. So this takes a server mux type. So this is a function on the server mux type. So if you see, it basically takes your handler function, means whatever function. So here we have this function as the parameter, pattern and parameter. So pattern is root route, and this is the function parameter. This is of type handler, means name is handler, and the function signature is this. Whatever it is type, it explicitly converts it into handler func type. So this is the from the, so it internally calls mux.handle. So you register the pattern with the to the mux.handle, and then you explicitly convert to the handler func type. So HTTP has a handler func type, which is actually an adapter, and which implements this function serve HTTP. So that functions once gets converted into handler func type, that type actually implement the serve HTTP. So that's how this conversion between HTTP func, handle func, and this to the handler func type happens, which in turn handles your request. Any question till now? Or have I missed anything, or did interpreted something in a wrong way?
So handler func, all by itself is it's a special type, right? Defined in the HTTP package.
Yeah.
And it implements the appropriate interface that has serve HTTP.
Yeah.
And then it handles calling your handler function for you when that interface's method is called. Is that, have I unpacked that right?
Yeah.
Okay. So which one should I use? Should I be using the one where I just pass in an anonymous function? Like, is there a benefit for making a type like you did where you had the message type implement the interface? Or is it just preference?
No, it's as far as I am aware, as far as I can feel it. So there are certain type, I mean, suppose you want to create an user. In that case, you want to have that type to be more predefined, do some pre-error handling checks and all those things. I might be wrong. There might be preference case also, but right now I'm trying to write one Go application where I'm trying to get away with the type, because I find that form conversion, schema conversion from form to the type makes more sense than having a function and do those things individually, doing those things individually.
Yeah. Have you gotten to the point where you're writing tests for your handlers yet?
No.
Okay. That would be really interesting. I'm probably going to suggest that for next week, actually, because I do wonder if maybe the anonymous functions are more difficult to unit test. That'd be an interesting question to answer. I don't know if other people have experience with that and want to share. Dead silence. I love y'all. It's okay. It's okay that none of us know how to do that. But maybe Aaron can help answer that, or Ankur can help answer that next week.
Yeah. So right now I'm not aware of any of those things, so I am not commenting anything because it's better to not say anything. Okay. So
the anonymous function, I'm sorry to interrupt. The anonymous function is not accessible anywhere outside, right? So maybe you could, the anonymous function, it won't be an anonymous function. So basically you could have the function defined against a variable and call that function inside, and maybe then you still have access to that function in the tests. But yeah, other than the fact that you would just want an anonymous function to just handle your code then and there. I'm not sure if there's any other benefit to going one way or another. Having a struct probably has, I mean, you have access to, some bit of stateful data and things like that. And maybe there is some amount of reuse that could be done, or even from a testability perspective, it might be easier to use that. Just my 2 cents. Actually, I've also not tested either of these, so not used this quite a lot. But just throwing in 2 cents. Thanks.
Well, this is really interesting. I didn't understand that under the hood, it was actually just wrapping it for me and making the interface for me. So it's good to know that they're basically the same thing. I really appreciate you walking through that.
Okay. Do anyone have any other? Okay. Okay. So this is the basic how HTTP means these 2 things becomes the same. Your handle func and whatever you register with handle pattern and the handler, and handle func pattern with the functions. So let me just quickly go through what are the steps once your request comes in, and once you register, what are the steps and how it's actually executed. Okay, so this is the basic. Once you have a client request, it goes to multiplexer, and then appropriate handler is called, and then the response is written to the client. So whenever your request comes in for suppose for root route over here, it will automatically call the appropriate handler for you, and it will write the response to the client. So how does this, where does this all the routes get itself registered? So we have this serv mux. So we have this, we are calling a mux here, multiplexer. We register this handle to this type only, whatever. So we have this, and this is the structure of the sermux. So sermux is basically it contains a map of a string, where string is your pattern, and then the mux entry. Mux entry basically contains your handler. So this is the process of registering. Here is okay. Here is the source code where you register your pattern. So we have a reader write log. So either you can just sermux you can read or write. So if you are reading it, you can have multiple logs. So, and if you try to write at that time, it won't allow. So this basically prevent you from any go routing, doing anything, writing any new routes, or in registering any new routes to itself, to this server mux. So that if you write, means any go routine, try to write any new routes, it will be deferred until unless there is any read log. Once that read logs is not there, it will try to write, because write logs gets more priority as far as I have read over there. I have never benchmarked it, means what is the case and all. So right, I have read that write logs gets priority. So once write logs get priority, you will get a write logs happens. You go routine writes a new route or add a new route, then you have a updated route. So this basically prevents you having a bad, means previous updated, you get a updated server mux at after each request. Am I clear, or did?
Yeah, I had a question about that. How often would people be adding new routes at the same time that you're reading routes across different Go routines? Normally, is this something that gets initialized like in a init function or in main before the server starts?
Yeah. Okay. So suppose as for okay, so I see it as this way. Suppose there is any third party router that is means that has been compromised, and it after certain time it spawn a new go routine that after that will sleep for 10 minutes after application has started, and it will try to write its own route into your server mux. If you are using default server mux, that's where actually security concern also comes in. You should not be using default server mux because it's a package level variable. Any third party package that you are using has been compromised, can register their own routes and can access your application in some way.
Is that also similar to say like some of the logging packages like glog, Glog, use basically global state, and it makes it very difficult to share and use that logger between various components. So making your own mux is just safer and less hassle.
Yep.
Okay.
So once we have this log, if pattern is null, if you don't provide any pattern, it will throw you invalid pattern. If the it's nil handler. So it basically checks if that pattern exists in the M structure. M is the map of string, and with this, so if that exists, we are trying to register the multiple go round pattern. If not, so here it, if M is nil, means if this is nil, if it has never not been initialized in the default case, it will make a new map and assign it to you, and then you can have a mux pattern registered over with this, becomes the key for the struct. So this is what your server mux after this registration pattern looks like. So here, once we have this registered, so we create a new server mux, we registered with the pattern. So for this route, we will have here root route, and with the handler mh1, whatever mh1, this is the handler. So it will pointer to that handler, and then with the mux entry. So this is the mux entry where. So mux entry, handler and string. So this is the mux entry, handler and string. This is the M. M is the route, that is a map. So this is the map of things.
I don't know if you're going to get into this later, but for pattern, is it just a regex expression, or is it globbing, or?
So pattern, as far I can see it, since it's a mux, it's a key to map entry. So key to map entry, I don't know if Golang allow regex to be there in the key to go entry, or is it simple a key which can be converted hashed value only. So that I have to still check, or anyone can jump in and say.
Yeah, I think that's where packages like the Gorilla Mux comes in, because that have regex, and because that's after what I've read, it's that's a limitation with the standard Mux.
Oh, thanks. That's really good to know. I assumed that it was smarter than that.
Yeah, it's a little weird. But one question, if it's okay, Ankur, because
Sure.
earlier when Carolyn asked about if it was a matter of preference to use one or the other, handler versus a handler func, you mentioned something about the struct, but I didn't quite, but it's my Norwegian English having to think about what's being said and translated in my head. But what was the benefit of one or the other, or what was it just a matter of preference?
Okay. So for me, like suppose we are trying to write for here, this becomes user. So for each individual user, for each individual response, once I have the user, I right now, whatever comes here, I can have various method attached to this type. So this message type can be received by any other method also, where I can do pre-validate certain thing, or where I can go and fetch network request and do certain kind of stuff. So that for me becomes little easier to write than writing over here all the conditions or calling. It's basically calling a type message, then calling your message directly.
Because well, one thing I also mentioned in my edit, so in my testing, is that correct me if I'm wrong now, but how I understand this is regarding a handler func, is that it's actually just a function that fulfills or satisfy the handle func interface. That means you can use as long as you write a function and you have parameters for a request and response, that becomes a handler func and is accepted as a handler, because a handler func is also a handler since it have a serve HTTP. Yeah. But what I also noticed that you can make a handler func with a receiver, so you can have access to the underlying struct if you want that as well, like you have done now with a message. You can do that the same thing with a handler func if you need to access some a data structure below.
Yeah, you can. We can do that also. So it's like basically you will be declaring a type, because you have to declare a type of that function. And suppose I want to do, I have to means. So then I can means basically it's declaring a type, and then only you can have this method satisfy, right?
Are you asking one of us specifically?
Yeah, I'm asking because I'm not aware of those parts right now. So that's why I asked.
The things I mentioned?
Yeah.
2 seconds, I'll try to find my GitHub. I have an example in my GitHub somewhere. I'll just continue and I'll post it in the chat, and just have to.
Aaron brought up a good correction about how the paths are matched. I put this in the agenda so it doesn't get lost when we close the Zoom, but he said that servmux matches prefixes, not just exact paths. So /blog will also match /blog/hello, unless there's also a longer pattern. Aaron, if you want to unmute and chat, by the way, I don't have to read your stuff.
Yeah. So I'm coming to that match also. Let me just. Okay. So can I continue?
Sure.
Yeah.
Yeah. So once we have this routes registered, we need a way to handle it, right? So how does this matching of the pattern happens? So basically this listen and so this is where listen and serve comes in. So it's over here. This is how you start the server. Once we have this server running continuously, it will listen for any request. It's a wrap over the net package that listens for the TCP connection over. And then once we have the, so here it is, listen and serve. Once we call this listen and serve, what it does is we provide the address and handler. So this mux is also a handler. This mux also implement a serve STT interface. So this allow us to write a middleware after this. Means we can wrap this mux in over the middleware and then call that also returns a handler. So it becomes mux also becomes an handler. Compose different middleware. It allows us to compose different middleware. So in this, So here is the type server that has this, for this, it returns a server, and then it calls for this server type, it calls listen and serve method. This listen and serve method, here it is, in turn calls server serve method, here it. So for each request, here we are running in a forever loop that prevents our server from getting shutting down. And then for this each request, we receive a request and we spawn a new Go routine to serve that request. So for each request, our server gets a new Go routine and that serves the request. So for, if you see that server type has a new connection, it's basically a same thing with where we get a new server and the new server and that returns it. So we call for this new connection, we call a serve method with the new context. So for this serve method, from this serve method, it's again in the forever loop where we call serve handler, where we pass serve handler type. We create a new anonymous serve handler type and call the serve HTTP method. So serve handler, basically whatever you have server, it returns this server. It initializes with the server and then calls the serve HTTP method. Since serve HTTP method, okay, here it is. So till now what we have the serve, so mux, this is the mux we originally passed to listen and serve method. So here we have this mux. This handler is the mux. So server has this handler, which is the mux that we originally passed. And then over here, it calls that function again and it assigns that mux to server variable. Then we call with the Go routine serve and it calls over here. It comes over here and it passes this server to this. So handler dot this server dot is basically containing our mux. So this is our handler. Since handler, this is where serve HTTP actually gets called. Since handler already implements serve HTTP method, we call that with the serve HTTP method. And that handler serve HTTP method, mux handler serve HTTP method, basically provides us with the with all these, how do we call, okay, here. So it's a handler with the serve HTTP method. Here it is. So here, so we get, so once we have this mux, this is the mux, right? What is the mux we get? So this is the mux for us. Here we get the mux from this return as the mux, whatever multiplexer we have. We are calling the serve HTTP method for that mux. So from that mux, we can have the handler. So mux.handler, it takes a mux and returns what is the handler. So this is our handler, whatever we have handler. So it returns an handler to us over there, and this handler function actually returns us the host with the matching parameter. So here you can see read locks happen. So every time that handler, again we are accessing the mux, original mux, so it has to read lock that mux from reading. So nobody can write to it. Once we have this lock acquired, we actually do the matching, and this matching happens over here. So this is coming from the Go doc only. So longest pattern wins. So path match happens. So I'm not providing any path match. This is another function. So it's basically exact path set to best match because it is or best match. So length of the path. So whichever is the lengthy path will be first matched, and then the longest path wins, whatever you were talking previously, Caroline.
Okay. Can I ask a question right now?
Yeah.
I can see that I'd want to be able to do common things for every request, regardless of perhaps which the handler function is. Maybe I want to log every request or keep track of how long each request took to complete, or if those go routines like panic and crash and die, maybe find some way to raise that up. Like, is there anything in the standard library that helps do common tasks across handlers, or is that maybe again something where you start moving to Gorilla or a framework like Buffalo or something?
Okay, so I haven't used any of the frameworks, so I cannot say anything about any of the framework, how they handle or what they do. And but I can see there for each request we are passing, we can pass this context also. They are doing certain kind of context. So I think with value, so with that context, I have seen this GIN framework where everything become context. So I believe that's where they are trying. That's where they manipulate. They write their own multiplexers and then manipulate and do it. But I cannot say with full confidence because I haven't used it or read any of their source code. And
do you know where the context is initialized, like who creates it or where it comes from? Is it just from the background context?
Yeah, it is coming from with over here.
Because I'm looking at like serve HTTP and the handler funcs, and it doesn't look like any of them let me pass in the context.
So context is created in your server with a type server in the serve method with value. Okay. So base context is also over there, if I'm not wrong. Seems like some modification has happened.
And it's okay if you don't know. I'm just, maybe some of these are better as follow-ups for the next
base
session.
Context with background.
Background. Okay, cool.
But sorry, but did you ask if it was anything in the standard library to do wrapping, for example, logging, and how long it took to fulfill the request? That was a good question, wasn't it?
Yeah, I was curious how much we could do with just a standard library versus when would you need to move to, like I said, either Gorilla or maybe even to something like Buffalo.
Yeah, if you want to add logging and take the time to fulfill a request and that kind of stuff, you can do that with a standard library. You just you create a function that accepts a handler as input argument and returns a handler.
Ooh.
So what it takes, and then you do something with that input argument of yours inside the function, and you call it, and you return it back to be used in where you put your routing and that kind of stuff. So you kind of embed them together.
Yeah.
If you
that was what we were actually looking at last week as well. So we had a really good session on that, if I remember correctly.
Yeah, that's right. So that's fully possible within the standard library.
Yeah. So Caroline, that's where I think we can write middleware, because since this.
Oh, I apologize. I went to last week's and I heard about middleware and I just assumed it was something that was Buffalo specific. I didn't understand that it's essentially a wrapper function that returns another function and could then provide, you know, common things across the handlers. So it's kind of neat. I didn't catch that from last time. There any other questions? I'm sorry, it's all me. I usually do back end and I never actually end up writing the server itself.
I don't think any of us should be sorry, because we are all coming from different parts, as you said initially, and so what might be the simplest thing for one of us might be hard for another one. So I had this talk with another guy earlier today, because I'm trying to understand the package layout, and I read tons of blog posts almost about how easy this is, but my brain don't see this as an easy thing. So, but of course, if you understand it, everything is easy. So I don't think you should be sorry, not at all.
Let me put that in like the agenda. Don't apologize for not knowing things. No apologies necessary. Like, it's so much. Thank you so much for walking through this for us. I learned a ton. I definitely have a bunch of follow-up questions I need to do more research on. If anyone else is interested in testing too, I certainly, like, that's what I would love to just dive into next, is how would I go about making this testable?
Sorry guys, my internet connection is really bad today. I don't know why. I got disconnected.
Oh, okay. I'm sorry. I didn't realize you got kicked off.
So that's how where the means knowing that this Mux is also an HTTP handler interface really makes you made me realize that I can write the middleware so easily. And suppose for any request I want to add requests correlation ID or anything to each request header, just that I have to set header with return handler function, means a HTTP handler that does for me and calls whatever this handler function serve HTTP method. That's all it takes to write a middleware now for me with the base pack means.
Yeah. So it's like a factory function that returns more functions.
Yeah.
Nice.
So I believe I'm mostly done with whatever I have learned with net HTTP package. So if you guys have anything to add, or if you guys want to say something.
Well, thank you so much. I think you may have missed it, but thank you so much for doing this for us. I really appreciate it. I don't know if there's any other questions before we close things up for today.
No, I don't have any, but I for sure learned that I'm going to dive deeper into the Mux part, because that is a fog for me. So, but this was a great start. So, yeah, perfect.
Thank you so much, everyone. Hope I get to see you again next week.
Yeah.
Bye.
Bye-bye.
Bye.
Thank you very much.
Bye-bye.
Bye.